as we start this off, you're probably going to say, all right, that's like the third time I've seen this. And it is. This is review time. We're going to review this and go over it pretty quickly. Yesterday, we spent a lot of time, Mason. And this for you might be a little different because I think you came in on the end of this, right? Yeah, so some of this might be new news to you. And that's fine because it's probably new news to some people at home too who haven't even watched the video from yesterday yet. We learned about El Nino and La Nina. And although I don't want to say they are 100% opposite, they're not like the complete opposite. They're pretty close to being the opposite of each other. So El Nino, as we jotted down some notes yesterday, I'll even do that again. Let me get to a new page here. El Nino, there are a few things that happen with El Nino. Not that one, Mr. Bullen. Oh my goodness gracious. 100 years from now, when somebody discovers my YouTube channel, where that guy has no clue how to use a smart board. El Nino, I think the number one thing at the top there is the water in the Pacific. Gets hotter. No, you've already written this down. Oh, well, except for a few of us that weren't here. That's fine. The water in the Pacific Ocean gets hotter. And Mason, we said yesterday, everyone in here already now has a really good idea of some things that's going to start changing. Because if I have really warm water and it gets even warmer, because this water in the Pacific is near the equator anyway, it gets even hotter, I'm going to have even more evaporation, which leads to more condensation, which leads to more precipitation in some areas. And that might be one of the first things we talk about, is because if you see here, it says it disrupts the jet stream with thunderstorms and it pushes the jet stream up in North America. In California, and we'll just put North Carolina, although it's like the southern portion of us, we get more rain, and sometimes there's floods. And it's not just us that gets the floods. If we start looking into this later on, we'll realize there's other places that get more floods as well. Those floods are going to be in like South America. We'll get more floods. With an El Nino year, and this is really easy to remember because the water gets warmer, guess what the entire globe does? All of the world typically gets a little warmer too. So if someone jumped on the news and said, just wanted to report we're having an El Nino year, 2021 is an El Nino year, you could probably start thinking in the back of your head, it could be a little bit more warmer and humid this summer. There's going to be a little bit more thunderstorms over the summertime and a little bit more rain. Not that we could get much more rain than we already have here. It's like it rains all the time. But, right, you would start thinking to yourself, wow, things are going to be a little different for me. If it rains enough, it could flood. Yes. So, but the thing is, it's kind of weird. It's flooding here, but, and I'll even write this in a different color. Australia and Southeast Asia, they're getting drought, which means it's not raining much at all, which is kind of odd, right? Seems like it would be raining even more. But as we watched the videos yesterday, we realized in an El Nino year, the trade winds that usually blow all that warm water towards Australia and towards Southeast Asia, those trade winds really start blowing very lightly, and that warm water moves the other way. It moves away from Australia and Southeast Asia, which if you don't have it as warm of water, you have less rain, which makes a lot of sense. As I'm looking at the anchor chart, I think we covered pretty much most of that. That takes me to, and I'll write this in blue, La Nina. Now, again, like I said, I don't want to say it's 100% opposite Mason. But El Nino, the water in the Pacific, gets hotter. La Nina, the water in the Pacific, gets cooler. The trade winds actually speed up during this, and they push all that warm water really close to Asia and really close to Australia. And it keeps it further and further away from the west coast of the United States and South America. So let's kind of look at this. California and North Carolina, they get more rain and some floods. Right? Guess what happens in a La Nina year? It can, I mean, if you look here, it gets to almost like very, very dry. I don't want to say drought, but it could be. It's drier than normal. We get less rain than we normally would. So that's the opposite of El Nino, right? I mean, it is the complete opposite of El Nino. Warmer temps globally during an El Nino. Guess what La Nina has? Cooler temps. For the most part. Not everywhere, but cooler temps globally. Australia and Southeast Asia, they're in drought during an El Nino. Guess what happens during a La Nina? They have flooding. Australia and Southeast Asia.
For Australia, a La Nina would be really good because most of them are just dead.
It's pretty dry there. Now, there's one thing about a La Nina. This is why I said I don't want you to just memorize opposites. And I'm going to write this in red because it's pretty dangerous. More active hurricanes. This is the important part. In the Atlantic. In the Atlantic Ocean. And Mason, if you ever have gone to the coast of North Carolina, you ever been to the beach? You ever put your foot in the water? That's the Atlantic Ocean. So is that important to us? Yes, because if a hurricane hits the coast of North Carolina, it can greatly affect everything. We've actually had hurricanes keep us out of school for over a week. Remember that? It was like 2 or 3 years ago. A couple years ago, maybe 4 years ago. But the reason why we were out is some of our schools were underwater. Like, not joking. Like the water was up to the tops of the tables in their cafeteria. Well, if they can't go to school, we can't go to school. It just doesn't work out that way. Now maybe we could do that. But then we didn't have the ability to do that. That's pretty wild, right? So this is very, very important for us to understand. Hurricanes can be very monstrous storms. They can be kind of just really like dump lots of rain and that's about it. It just depends on what's going on and how much power they build up. Now that brought us to something yesterday that we talked about. Hurricanes need a lot of warm water. Warm water is what really feeds hurricanes. So La Nina season, active hurricanes. This is the Atlantic Ocean. This is us, by the way, North Carolina. What is this warm current of water that goes down and around Florida and up the coast of the east coast of the United States? Mason. It is the Gulf Stream. Hurricanes love warm water, don't they? So that Gulf Stream, especially if the hurricane comes up and hits this way. But even when it comes this way, that last bit of warm water, I joked yesterday, I said it's kind of like drinking a Red Bull for the hurricane right before it does its business on the land, right? It's like, I've got a lot of energy, but I'm going to drink that Red Bull and I'm coming at the coast pretty hard because it is able to pick up a little bit more energy from that Gulf Stream. If it comes through this way, that's a lot of warm water, isn't it? Hurricanes can pick up a lot of power. And if you remember, Hurricane Katrina, right? When it went through and it just demolished New Orleans. Remember that?
And
Well,
Hurricane Laura.
we're all down in here. Why was it able to do that so much so? Well, number one, it was a massive hurricane. Number two, that's like a 6-pack of Red Bulls for the hurricane right there. That's just crazy talk, right? You can't have that. I mean, it's insane.
That's how Hurricane Laura.
And we've even like looked at some articles where they've actually researched ways to try to cool the ocean off ahead of a hurricane. I'm gonna like dump ice cubes or something in the ocean, but I mean seriously, like no, like not joking. Like that's kind of the stuff that they've looked at. Are there ways that we could defend ourselves from these massive hurricanes by cooling the waters off? Because if we do, the hurricane would lose a lot of its energy. That's a thought. If somebody figures it out, you'd be a billionaire. Just letting y'all know.
Get a gigantic ice cube.
Huge ice cubes. All right. So again, Mason, as a super quick review with these slides. El Nino is a climate pattern where the water in the Pacific gets warmer than usual, hotter than usual, and it affects weather around the world. Right? Up until this point, we were saying low pressure here means lousy weather here. High pressure here means happy weather here. But if there's a high pressure in Winston-Salem, does California care? Doesn't affect them at all. El Nino and La Nina are different. They affect weather around the entire world, which is kind of a neat thing. We said that El Nino can change the weather of the United States. California and North Carolina get more rain and higher temperatures. We said that for us, it causes an increase in temperatures. The summers and the winters tend to be a little bit warmer. So if it's an El Nino year, you may not get a whole lot of snow that winter. Well, if you look back, it's funny, Mason, if you look back at the last El Nino seasons, and I'll do that real quick. Again, with the ocean heating up like that, we talked about more evaporation. More evaporation means more condensation. More condensation means more precipitation for the areas that are affected by that. I would go back and watch that, but we'll have to watch that another time. Then there's La Nina, which in a lot of ways is very opposite, but not completely opposite. The water gets colder, which is opposite of El Nino, and that changes things because that makes all the hot water get pushed this way, and it's over, or actually, yeah, this way. So make sure I was in the right spot there. When the water gets pushed to the west by those trade winds, that means all of the weather gets pushed that way. So Australia and Southeast Asia, who were in drought during an El Nino, during a La Nina, they're getting just absolute tons of rain and even floods. So things kind of get switched up on them there. We've noticed that the jet stream is always affected by El Nino and La Nina. And I think that's where we kind of need to start talking today, is a little bit about the jet stream. And again, I don't think any of this is new information, is it? Because you've already done this if you did the work after the benchmark. Jet streams. A jet stream is a river of wind that separates two different temperature air masses, and it would look something similar to this. So a jet stream is a river of wind that separates two differently temperatured air masses. So, and here's a jet stream that goes across the United States. I don't think anybody in here is shocked that it's cooler up here. The air mass is cooler up here. I mean, is anybody shocked that this area is colder? No, because if we were to travel, right, we're starting to get into places a little bit cooler. Nobody is shocked that these areas are a little bit warmer, especially down here in Florida, right? Now, that jet stream can bounce around all over the place, especially when we have El Ninos and La Ninas. If I know that the jet stream can dip pretty low during a La Nina season, then what that means is there's cooler air being pulled down into places in the United States that aren't typically as cold. You've got South Carolina, Georgia, even like the top part of Florida there. That's not usually as cool as it can get. When I say cool, I'm not talking it's in the 40s. I'm saying a summer in Georgia where the average temperature is like in the upper 90s. Now the highs are like 88. Still hot, but cooler than it would be. That actually might not be a terrible thing, right? Other than the fact that it would be drier and not a lot of rain. And then these places down here